let's start with, I think this will put it in. Okay. Probably the worst section of binomial is this one. It's really bad because it gives you absolutely no direction of what to do. It just says show, evaluate, simplify. This one at least gives you something. It says use differentiation, but that's it. So a lot of students struggle with this. There is good news if you know how to do it. The answer is actually in front of you. So as much as it just says show and you think it doesn't say anything else, actually it does. The answer is in front of you, and that's what I'm going to teach you today. And if you guys can see the answers, you're going to make your life super easy when you learn this, because it isn't hard. So to me, when I realized the answer is actually there, very, very straightforward topic. A lot of my students who try to actually learn it and try to understand it, you won't be able to, because to actually execute the question, you've got to do something that's very unique. Okay, let's start. First, we've got to learn how to expand 1 plus x again. So, let me just lock this in case we've got to write anything on it. Page and selection lock. All right. Expand 1 plus x to the n. The expansion, if you guys remember, was n choose 0. Right, you start with the 0 first, then you're going to do the first one to the power of, let's say, n, which no one writes. We'll write it for now, and then you'll technically do your x to the power of 0, which again, no one writes. So essentially your first one is n choose 0. The top line I'm going to put in what it's doing. The bottom line I'm going to put in what you're actually going to write. So technically, no one writes the first line. All right, you guys are just meant to do the second line. But I'm just going to show you what's happening. Plus, the next one you always do is n choose 1, the one after 0. Then you'll decrease this one by 1, which is obviously, again, no one writes it, but there it is. You increase the other one by 1. So that essentially means you're going to write n choose 1 x. Plus, then you increase it, decrease it by 1, increase it by 1. Plus, any questions at this stage? Anouk, any questions?
No.
No, you can see the expansion of this? It makes sense?
Yeah.
And what do you think the last one's going to be then? The very, very last one. N, choose?
4.
Last one. Think
Not
about
sure.
it. You said 4. You only said 4 because that's the next one. But the last one, think about this with any number if you guys want to. What should the last one be whenever you're doing n choose 0, n choose 1? Maybe, yes, the last one has to be n choose n. Right? Isn't it 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4? The last one is 5 choose 5, itself, choose itself. And then x to the power of?
N.
N. So the way I see it, look, 1, 1. We're trying to look for patterns. 2, 2. 3, 3. N, N. Let's not make it too hard. It's easier to see that way. Again, it makes sense because remember, you're going to keep decreasing your 1s. You're going to keep increasing your x's until the last one. And the last one's going to be x to the power of whatever. So it looks confusing. Let me do a basic one for you guys. One that you're very comfortable with, hopefully by now. There, 3. That's going to be n choose 0 plus n choose 1 x plus n choose 2 x squared plus n choose 3 x cubed. Sorry, not n. 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3, but you get the idea. If it was n, it would be exactly the same thing. But yeah, 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. No x's, increase the x, and the last one's obviously going to be x cubed. So before I continue, every single question in these proofs will require this expansion, whether you like it or not, whether the question asks it or not. You have to know, Sam said, I've got to always do this. That's what I meant by, it's not going to tell you what to do, you've got to know what to do. So, any questions before I continue from this step? I think I said it last week as well, yeah, algebra is going to be really good after this topic. All right, A. A says, show that n choose 0, I'll do it on purpose like this, n choose 1 plus n choose 2 plus ... plus n choose n is the same as 2 to the n. Show. I think, Mariette, maybe you remember. What are you meant to do with a question like this? If you do remember. We are trying to prove left-hand side equals right-hand side, but there is obviously a trick. Mariette, do you remember at all?
I'm just trying to remember.
Yeah, okay,
I know
cool.
the first term and the last term equal 1.
The first, okay, good. Yep, but you don't need to you don't need to you don't need to change that just yet, because that's already given you as n choose 0 and n choose n.
Yeah.
So you don't need to change it to ones. Other questions you will sometimes. So it's good that you saw that. You don't need to do it now. Sorry, what was that?
If you let x equal 1 and you expand it out as 1 plus 1 to the power of n, could you do that?
That is exactly what you're meant to do. Well done, Lucas. So, what you guys got to start to realize with these, like I said, there is a trick to it. It's comparing what you have in front of you to what you just wrote. So what's the biggest difference between these? Let's say these, and these, and these. What's the biggest difference you see? Well,
X.
there's no x's. What happened to your x's? What happened to x? Where did it go? The fact that it disappeared is telling you the answer. It disappeared somewhere. Look at the left side now. It's 2 to the n. What does that mean x must be? 1 plus 1 is 2. So x needs to equal to 1. You've got to let, out of nowhere, out of thin air, like a magician you are, you just let x equal to 1. You can actually let x equal to any number, but it's about observing what you can see here. If x equals to 1, I get 1 plus 1 to the n, and then on the right hand side I get n choose 0 plus n choose 1 times 1, which is just n choose 1, n choose 2 times 1 squared, which is just n choose 2, plus all the way until the end. They're all just multiplied by 1, which doesn't do nothing, therefore you just proved the result they wanted. Good. Very good. All right, let's try that again. B. B says evaluate now. So let's find as a number, evaluate. It's important you understand evaluate. The word evaluate means find the value of. That means that needs to be a number. So find n choose 0 minus n choose 1 plus n choose 2 minus n choose 3 plus ... plus n choose n minus 1 to the n. Okay, Novak, you're going to give this a good shot. Again, you're going to compare. Obviously, which two are you comparing? You're going to compare the original one, there it is, to this one here. And you've got to say something again that's standing out to you. There's no x's. So again, you know something's going to happen to your x's. But otherwise, everything else is the same. See, NC0, NC0, NC1, NC1. But then what's also happening with these? But then that's it's alternating, interesting. It's alternating every odd one as well. Okay. And then keep reading this, keep reading this, keep reading this, keep reading this.
-1. So x is -1.
See? See how simple that was? It looks very fancy to you. The way we read it, the way I read it, is obviously right there. That gives me the answer.
So you're basically comparing the original.
That's what you're doing. You're basically comparing your original to whatever they ask, what they're asking you to find. Can you guys see it now? X, let x equal to -1. Again, you realize the x's are gone. And then I said, okay, it's happening to every odd, which is rather interesting because -1 to the power of an even number is always positive, but to the power of an odd number is always negative. And then, of course, the last one, it says x is -1. Look at it. Bang. So you let x equal to -1. Your answer is 1 plus -1 to the power of n, which is, of course, 0. The answer to this will be 0. All right. Questions, you guys? See, I told you, at first glance, it looks like it's just a whole bunch of everything, but like to the trained eye, you actually can tell the answers there. So I hope you guys remember this for when you do it at school. All right, n choose 0 plus 2, n choose 1. All right, hold on. N choose 0 plus 2, n choose 1 plus 4, n choose 2 plus ... plus, what did I say? Plus 2n, n choose n. Plus 2 to the n, n choose n. All right, Anouk, you can try it out. Again. Oh, it's very hard to compare.
Why did you say using differentiation?
Incorrect. I like that you're trying that. Can I tell you why you're incorrect?
Why?
If you said differentiate this term, n choose 0, does it have an x?
No, so it's going to be 0.
So it's a constant, which means when you differentiate constant, it's 0, so it shouldn't have appeared, but it's still there.
Okay.
So I like that you said that, but you can realize it's not differentiation now. Cool? All right, go. Give me another idea now. Keep comparing.
X equal 2.
Double check it, double check everything, and there it is, xn, x to the n, 2 to the n, n choose n, n choose n. X is 2, yeah, that makes sense, 2 squared, 2 cubed.
Yeah. So let x equal to 2.
And that's it. Let x equal to 2. You know the expansion of this is 1 plus, obviously, x to the n, so the answer is 3 to the n. Can I make it any easier?
No.
No, I don't think so. This is really poorly done by Year 12 students. But I can't make it any easier for you guys now, being Year 11 students. D, last one. I mean, don't get used to it. You won't probably say this. So don't get used to that. Just learn to look at it. Keep learning to observe what you have with what you need. What you have is this line up here, the original one. What you need is obviously what they're asking you to show. So let me write it, and maybe this time you guys can see how this is actually a derivative question. 3n choose 3 plus ... plus. Did they do the last one? Yes, they did. n choose n equals n bracket 2 n minus 1. Was that it? All right. Now I'm just going to scroll down. I'm going to write down the original again, just so we have that. The original was n choose 0 plus n choose 1x plus n choose 2x squared plus dot 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 plus n choose n x n, which I'm sure we can memorize eventually. Okay, what's the one thing, if I was to look at this question, I'll be like, oh, well, what happened then? Where's my n choose 0? I think that's the first thing I would realize, right? It's not, there's no n choose 0. I'll be like, the only time I know that to occur is two cases where n choose 0 won't be here. Case 1, the obvious one that we now know, differentiation. Case 2, Maria, you said it originally before. When would NC0 not be here? When NC0 is what?
1.
1. When NC0 is actually 1. So what they did to trick you guys, they, let's say, replaced it for a 1, or what they did was, instead of even having a 1 on this side, they wrote exactly this question, but they put minus 1. Because then that gets everybody. That's like, oh, how do I do this? Blah, blah. Or those who get it, they usually do differentiation, but then it doesn't work out because it's not differentiation. And so you guys got to remember, if n choose 0 is not there, it's usually differentiation or this case, where this is just equals to 1. Good. Now that we've wrapped that around, let's do this question. We obviously know this one's a derivative. What gives it out to me, other than the fact that it's not case 2, is this guy. Oops, let me rub out a few things here. This guy, look at it. Power of n minus 1. And then I dropped the n, I took away 1 from the power. So that gives it away to me. I now know it's a derivative, but oops. Let's do it. So the original was this, equals to 1 plus x to the n. So I'm going to differentiate the original, right? Oops, differentiate the original. If I differentiate the original, n choose 0 is gone, n choose 1x becomes n choose 1. That's just a number, so don't forget that. X squared, you drop the 2 down, I'm left with n choose 2x plus, if it was cubed, I drop the 3 down, x squared, I take away 1 from the power, I do that until I get to the last one, I drop the n down, I take away 1 from the power, and then n choose n. That needs to equal to, drop the n down, take away 1 from the power. And then usually with chain rule, if the inside was something else, I would multiply by the derivative of the inside. This time I don't have to. And that is how we differentiate the original. Not hard. I swear it's not hard. It really isn't hard. Right? You're just dropping the 2 down. These are constants, so just leave them and choose 2 or coefficients. And yeah. Obviously, look what we wanted, NC1 plus 2NC2, 2NC2x, 3NC3, 3NC3x squared plus dot 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 plus n only. I've got n x n minus 1, n choose n, and I need it to be n 2 n minus 1. I have n 1 plus x n minus 1. What's my next line? To finish this off,
X equals 1.
yeah, right, again, x equals 2, 1. 1 plus 1 is 2, so I get n, 2 to the n minus 1 equals nc1 plus 2 nc2 plus 3 nc3 plus dot 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 plus n. 1 it disappears, ncn. Finished. It's not hard. We're gonna do plenty more. Don't worry, but it's just gonna be the same thing. I'm actually not gonna do anything amazing. It's all gonna be the same math. So copy that down. I'll give you guys a minute. I'll be right back as well. Once copied down, if you feel like you're ready to get started on one, scroll down to that booklet and try this one right here. This just means n choose 0, by the way. You either write it in brackets or you put n choose 0 plus n choose 1. Okay. I'll go back to this. If you feel like you're ready, try to prove that result. I'll be right back. All right, so this one here. See, prove. Let's get straight to it. Prove. Example 25. Okay, what's our starting point? What do we need first?
One plus x to the power of n.
Yeah, equals. You need that first. Cool? So n choose 0 plus n choose 1x plus n choose 2x squared plus dot dot dot. Has to be 3 dots. Minimum. Plus n choose nxn. Come on. I'm sure we see it, right? What do we do? Shania, what are you going to let x equal to?
1.
1. 1 plus 1 gives you the 2. That's how we're going to look at it. Everything else, just make sure it works. N choose 1 when x is 1. I am pretty happy with that. X equals 1. Therefore, you would get 1 plus 1 to the n is n choose 0 plus n choose 1 plus n choose 2 plus dot 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 plus n choose n. 2 to the n equals the above. Very, very straightforward. That is an exam question. That's the good news. So with this, there's no, I guess, difference between a textbook or an exam. It's exactly the same. So whatever you get taught there, that's exactly the question you'll get in your exam. So nice and simple. Don't make it more difficult than I just made it. All right. Obviously, this one here, what do we reckon? Just by looking at it now? Yeah. Wait. So what's your x? Realize one. Say it again.
Should equal minus 1?
Yeah, minus 1. You realize minus 1 to the n, x equals minus 1. What gives it out? Again, to me, it's this one. So, again, we're going to... If this was a standalone question, you have to understand, if it's a standalone question, you start with 1 plus x to the n equals n choose 0 plus n choose 1, x plus minimum 3 terms, 1, 2, 3, then plus dot 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 plus n choose n x n, and then of course x equal to minus 1, and you will prove the result. Up to you. If you feel comfortable using the bracket notation, you can. If you feel comfortable using the choose notation, you can. You pick whatever you're comfortable with. I told you guys, I think last week, the only reason why I don't use the brackets is because I teach younger years as well, and I have a tendency of doing this because I'm teaching them fractions still. But if I was you guys, you don't do much work maybe with fractions as much as the younger kids, so you might actually get used to the brackets. It's a bit faster, you don't have to keep writing C's. But whatever, doesn't matter. Okay, good stuff. I think we've smashed this. See, this one, then you get to a question like this, and then that's when you guys are like, what is that? And what does sigma mean? Sum.
Sum.
Sum of. So prove 3 to the n is the sum of n choose k, 2 to the k, with k being 0 as your first number and n being your last one. So this is actually everything that we're used to. It's just written in a shorter version. So pretty much prove this, i.e. prove 3n equals k is 0. So n choose 0, 2 to the 0, which is just nothing, but we'll just leave it there, plus n choose k is 1, that's your next term, 2 to the 1, plus n choose 2, 2 to the 2, plus dot dot dot, plus n choose n, 2 to the n. Like I said, everything we're used to. Maybe before I wrote it like this. There you go. And I think we already know from just looking at the left-hand side, x must equal 2. 2. 1 plus 2 is 3, 3 to the n, and everything else looks like a workout because 2 squared, 2 squared, 2 cubed, whatever, until 2 to the n. So don't let that sigma sign confuse you. Same thing. We'll do that one. Let me just see if there's any. Actually, we'll do a derivative one. Yep. Oh, we just did that one. Let me see if I can find it. Okay, there we go. HSC question 2. Yeah. I feel like, okay. Obviously, they told you by applying the binomial theorem to this and differentiating show this, and I think we can show that. I just want to make sure double I. Who thinks they know what to do with double I? Compare the pair. What do you guys reckon? Oh, you're stalling. You shouldn't be stalling.
You'd sub in
Say it.
x equals 2.
Yes. X is 2. X is 2. X is 2. Don't let this confuse you. This is just saying it can be any letter R, R, R. It can be any letter N, N, N. So don't let that confuse you. That's just, it's just trying to tell you there's something in the middle as well, which there obviously is because it's going on forever. All right, you guys try it, and then we'll see how far you get with your working out compared to what I would do. So first expand this in your first line, then try to see if you can differentiate it and get the result. If you do, try to see if you can get your last mark as well in double A. And choose 0. Oh, got it. Are you writing the proof? Okay, sorry. Okay, you got the expansion right. Now start with that line and differentiate. Differentiate that, differentiate this. Okay. Now, from original. All right, let's see how it went. Anyone feel like they got it all out? Not yet. All right, let's see. N choose 0 plus n choose 1x plus n choose 2x squared plus dot 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 plus n choose nxn. We're okay with that line? Now what? Differentiate. So differentiate this guy. What do we do? Drop the n, keep the bracket the same, take away 1 from the power, and then usually multiply the derivative of the inside, which doesn't matter in this case. Equals n choose 0, constant. If it was like 1, that's gone. N choose 1x, anything in front of the x, you disappear the x, and it's just n choose 1. Plus, you drop the 2 down, n choose 2x, plus 3, n choose n. 3, n choose 3x squared, plus dot dot dot, plus n x n minus 1, n choose n. We're done. Yeah. What do you mean? Isn't that the same? N, x n minus 1, n choose n. I ignored the r because, like I said, that's just exactly the same as the n, except it would have been r. If you wanted that r, you don't have to, because you've proven it already, it's the same thing. But if you wanted that r, just so you guys understand, it's our business.
Sam, would this just be worth 1 mark?
This, no, 2.
Oh, okay.
And then this is worth 1 mark. 3 marks altogether. And choose 0, where was I? If they didn't say differentiating, then it would be worth 3 marks. But the fact that they gave you what to do by expanding, see, by applying the binomial and by, like, they gave you everything, they can only put it as 2 marks. But if they didn't, and they just said show, that would be worth 3 marks. This would still be worth 1 mark. Where was I? N choose 2 plus, oh yeah, here. And then this could be n choose r, x to the r, right? Plus dot 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 plus n choose n, xn. And then when you differentiate this, it'll look like r, n choose r, xr minus n. It's nothing fancy. It's just telling you that it can happen for any r, just like it can happen for any number here. Okay, and then of course, sub x equals 2. 1 plus 2 is 3 to the n minus 1 equals n choose 1 plus dot 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 plus n, and then x is 3, x is 2, sorry, 2 to the n minus 1, n choose n, 2n minus 1, n choose n. I'm happy with that. Done. Any questions? To me, I personally really find this an easy place to get marked compared to perms and coms. Permutations and combinations, obviously the questions are valued the same, they still might be worth 3 marks, but the math is not so repetitive, unfortunately, because the questions are not very repetitive. This, there's no reason why you shouldn't get full marks for it. Okay, and again, and again, and again, 2011, the binomial theorem states this, show this by differentiating the result, assume that n is even. Yeah, let's do this. Just because it looks a little bit harder, I'm sure for you guys, you'll find that a little bit challenging. Let me just see, these are all the same. That's what we just did. What year was that? 2016. See, it's all the same questions, right? That's just how they work. But anyways, okay, good. Let's finish it off. We're up to equating. It looks like, I think from what I can see, we might just have a bit of time to start perms today, and I can pretty much get to it from next week. All right, here we go. Binomial theorem, 2011. Question 7 with the old papers. This was the last question of the HSC. So last question, right? That means obviously tough. When it's worth 7 marks, the old papers were worth 12 marks a question. So if you can just answer this one question, you've already passed, which is great, because in extension 1, our exams are worth 80 out of 84. I think the new ones are worth, I'll double check, I think they were a bit less, I think they're 78 or something, I'll double check it. 84, our aim always was to get to, 65 out of 84. Pretty much 77%. And then you'll get scaled up to 90% in extension 1. So just so you guys remember, your benchmark is around 77, 78% in the HSC. You hit that raw, you get scaled to the band 6. And really it isn't hard. When you get like in last question out of 12, you get 7 already. Usually for us, it's always been a pass. If you can pass the last one, then you already got a 77% guaranteed. If you can't, that means you're not there yet with the other questions either. So usually if you can get past question 7, then question 6, 5, 4, 3, 2, 1, you're already done well. Okay, anyways, back to business. Binomial theorem states this, which we know is true. N choose 0, x to the 0, n choose 1, x to the 1, n choose 2, x2, n choose 3, x3, n choose 4, x4. We see how that happens. And until all the way to n choose n, xn. So they've just summarized that in terms of sigma. So let me just write it the way we like it. 1 plus x, n. Always do that. Don't use sigma. I don't care how good you think you are. Don't do it. So expand it. N choose 0 plus n choose 1 plus n choose 2. And just make sure you can see how that's working. This means sum, so plussing. And all you're doing is start from 0, and then n choose 0, you replace the r, and then x to the 0. Then you go with the next number, 1. N choose 1, x to the 1. N choose 2, x2, plus n choose 3, x3, plus all the way until n choose n, your last one, xn. Anyone not sure how to expand that using sigma notation? Okay. I show this. Again, I don't recommend reading like that because you're not going to get it out. So what are we going to do? We're going to go IE, just for yourself. So this is what you're trying to prove. N choose 1. N choose 1. 1, x1, which is just x. Right? Plus, r is 2. N choose 2. N choose 2. R is 2, so 2x squared. Plus, n choose, let me just make sure, 3. 3x cubed. Ah, interesting. Plus, and then dot, 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 all the way until n choose n. N choose n, nxn. Equals n x 1 plus x n minus 1. Let's see if you guys are able to get this one out. Even if you can't get it out fully, just talk to me with what you can see. what you can see. So compare now. Compare this. Obviously, you're comparing this to this one, and you'll compare this one to this one. All right. Give me some things. It's important that you just say whatever you see. There are coefficients in front of the x's now. Ah, okay, cool. Yep. Interesting, isn't it? So it's not like, hey, you can just go and say, let's substitute it, because the x is still there. So that's pretty interesting. Anyways, yep. Come on, what else do you guys realize? Yes, bingo. That's either a 1 or something else, remember? Then, keep going, what else? Then look. You think you know it? What's happened? I think you got it. If you just put 2 and 2 together now, you got it. Can you put 2 and 2 together? They did what? They and correct. Yes, keep going. Not sure if you guys can hear Novak, but he's saying n choose 0 is gone, which I think we can hopefully all agree with. Then you remember there's 2 cases, which is this is 1 or that is differentiation. It doesn't look like it's the 1 because there is no -1 anywhere or +1 anywhere, so it doesn't really look like that. Then you can probably see that's a derivative, and he did realize, but there's something, but he hasn't put 2 and 2 together. So can someone tell me what they think to do until he works it out as well? How does this link to this?
How do we get the x in front?
He's asking, how did they get the x in front? Lucas, any ideas? How to go from here to here? Anyone can answer his question. How did they get x in front? Not yet? Help him out. How does he get an x in front?
I'm just as lost.
Oh, wait, listen. Be creative. What are you going to do? What are you going to tell him to do?
Multiply by x.
Done. And I know you should be able to do that because you've done that a few times with other topics now. Whatever, you want the x, it's annoying you? Great. Multiply everything by x. What happens all of a sudden? When you differentiate, isn't n choose 1, x just going to become n choose 1? That's why you've got the x there now. Isn't this meant to be a 2 and then x to the power of 1? But that's why it becomes x squared because you've multiplied it by x again. So you had a problem, you just didn't that finishing touch. The problem was the x, easy. It's just telling you to multiply by x. The answer to your how is there. You're like, how did I put the x? Well, they just multiplied it by x. It's right there. All right, you guys. Once we can see that, let's do this. So start from the original. We're going to differentiate. Start from original and differentiate. Drop the n, 1 plus x, n minus 1. That gives it away to me. The n minus 1 and the n like that, it's a straight giveaway that it's differentiation. Anyways, did this question even say it? It didn't. It just says show. You see? Those are the harder ones. And to make it even harder, they put it as sigma notation. So hopefully we know, no, don't use sigma, use the IE. All right, bang. And then that becomes NC1 plus 2 NC2 x plus 3 NC3 x squared plus dot 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 plus n x n minus 1 n choose n. Then I look at that and I'm like, what? So close, but it's got an x. And then obviously that's when we realized, before I even started, I'm trying to show you that you're meant to know the answer before you start. And then I'm like, oh yeah, of course, you multiply everything by x, so times x. Is that allowed? Yes, as long as you turn it to everything, there's nothing stopping you. So you can multiply by x, just like we did substituting x is 1. You can do whatever you want, as long as it's to anything, or everything, sorry. And x and choose 1. I'll put the x on the outside. Let's put it in the inside, just to make it look like this. And choose 1, x. Pretty much, I just rewrite the question there. So you're not really meant to like multiply by x, you're meant to just rewrite the question, because you already told us what to do. N choose 2, 2x squared, plus dot dot dot, plus n choose n x, n. This multiplied by x, 1 and minus 1 cancels out, you got x to the n. And then n, x, n choose n. Happy days. Finished. 2 marks. 2 marks for something that we've done left, right, and center. Just that x. And you said it. You said it's multiplied by x, but you just didn't put it together. You were close. Double I. Double I. All right, let's see. Anyway, any questions from I? All right, double I. By differentiating the result from part I, they gave that to you. Or otherwise, show this. Again, before we start it, let's write down what it's saying. i.e., you're required to prove n choose 1. N choose 1, 1 squared, plus n choose 2, 2 squared, plus n choose 3, 3 squared, plus dot dot dot, plus the last one's n choose n, n squared is equal to n bracket n plus 1 to n minus 2. And it obviously has given you the clue. It says by differentiating the result from part 1. All right. Zoom in. Step 1. What are we going to do? Step 1.
Step 1. Differentiate.
Why are you looking at this like it's all gibberish? Because it is.
Yeah.
But there's a way of looking at it, and it's telling you differentiate the result in part I. So if you're not going to start that as your step 1, you know you're not going to get anywhere. What do you realize is different then, other than the fact that it's differentiated? What else is different?
All of them are squared.
Sure. We'll get to that in a second. I like that. All of them are squared. Yep. And what else? What's even bigger than that?
There's an n minus 2 on the other side. Does that mean second derivative?
But doesn't that mean it's going to come from the derivative? Because aren't you differentiating and then this is going to become n minus 2?
Is that the second derivative or something?
Yeah, it's going to be the second derivative of this one.
Yeah.
Like, I mean, first derivative of this, sorry. So you don't need to think of it as second derivative. But keep going. What else is different? You guys are overthinking it by a mile.
X will equal 1.
Something like that. Don't worry, you don't need to say the answer. X is missing.
Yeah.
X is missing. Right? You just worked it out. Step 1? No. No. Step 1.
Differentiate.
Step 1, differentiate. Step 2. Yeah, you got to substitute whatever the x value is that you're going to work out. Okay. Ready?
Yeah.
Let's do it. Step 1, differentiate. Let's start with this right-hand side. So, differentiate I. Differentiate I. And choose 1x. And choose 1 plus 4x. 4x, and then n choose 2. I think we should have another one so you guys can see it. So this would have been, no, No, hold on, up here. Times it by x. This would have been 3x cubed, and choose 3, right? 2, 2, 2, so 3, 3, 3. Yep. So this would have been another one. This would be the one after this. So then differentiate this. 3 times 3 is 9. X squared, and choose 3. Plus dot 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 plus. Bring the 2 down. No, sorry. What am I doing? I'm doing this one up here. Bring the n down. N times n is n squared. And then x, n minus 1, n, choose n. Differentiating I. This is I. Any questions at this stage? That's the right hand side. Now we want the left hand side as well. So that equals, which looks like a beautiful mess. How do we differentiate this? There's something that should stand out to you when you're thinking of differentiating that. Think back to your derivatives.
Is this product rule?
Why?
Because the x is in front as well.
Yeah. I always said if it's multiplied by 2 x's, product rule. So equals u dash, the derivative of nx is nv plus v dash u. So v dash is n minus 1, 1 plus x, n minus 2 times u, nx. We did say question 7, right? We're talking about high band 6. So they need to realize when you see a question like that, that's going to be a product rule. Okay. I'm still not happy because I can see my right hand side, it was all like one big expression. This does not look like one big expression. So, but then I realized something. Look at this. Look. Oh, what? 3 squared is 9. 4. N choose n, n squared. Ah, I think I got it. Anyone see what x equals? What is x equal to? Look at this. Isn't 2 squared 4? N choose 2 is n choose 2. So what is x equal to?
1.
How can you say squared? 1.
Oh, 1, yeah.
4 times 1 is 4. 9 times 1 squared is still 9. 3 squared. It's exactly the same.
Yeah.
It's just x is 1. Let x equal to 1. Remember, step 1, differentiate. Step 2, get rid of your x's. So this would look like this. nc1 plus 4 nc2. And look, can you see where your squares are coming in now? 9 nc3, because 9 is 3 squared. 16 would give you 4 squared, and so on.
Sam, I don't know. I didn't understand how you got x equal 1.
Okay. So again, compare. Can you see that's 2 squared, which is 4, nc2, nc2. Remember, this is what we're trying to prove, right? We're trying to prove this black line. So I'm comparing this to this, and I'm like, well, what does x equal to? What would x equal to? What's the difference between these two? nc3 is the same. 3 squared is 9. My x would need to equal to?
Oh, okay, I see.
1. N squared is the same. NCN is the same. That's just 1.
Oh, okay.
Anybody else? You guys are overthinking it. I think you're not realizing that it's usually x is 1 or -1, never 0 because that just cancels everything out, and sometimes 2. Maybe -2, but that's it. Like 1, 90%, -1, 5%, 2, 2%, -2, whatever's left, 2%, and then 1% for anything else that's left. 3, -3, whatever, but like really it's going to be x equals 1. All right, right hand side. Remember what we're trying to get. We're trying to get this bad boy. So n dot 2 to the n minus 1 plus n minus 1, 2 to the n minus 2, and then times n. It's messy. There we go. Agree or not agree? I just subbed in x is 1 into this side. And then that's what you should get. Next line, nc1 plus 2 squared, because that's what you wanted. You didn't want 4. So I'm just going to write it the way they wanted it. nc2 plus 3 squared, nc3 plus ... plus n squared, ncn equals, all right, this thing. What would you do now? When you know it's going to become 1, you've got it like this. What are we going to do? Common factor. So now it's got nothing to do with binomial anymore. Now we're going to factorize. So when you're factorizing, n and n is a common factor, factorize it out. There it is. With your 2's, you always use the smallest one when you're factorizing, right? Smallest one's obviously this guy here. So that's 2n minus 2. If you're struggling with that, the clue I can give you is the answer is in front of you. So if you took out n minus 1, why? It says n minus 2. All right. And then 2n minus 2 times what gives you 2n minus 1? Power of 2. Why? Because if that was a power of 1, minus 2 plus 1, it gives you minus 1. Plus, what's missing from this, and n minus 1. 2 minus 1 is 1. This becomes n plus 1. And you're done with the result. And 2n minus 2, n plus 1. Obviously, these last 2 marks are not the same 2 marks you would get in a question 4 or a question 5. You guys got to remember that 1 mark in question 7 can take a page and a half. That's it. Completely allowed. Okay. All right. Anouk, are you starting to see a pattern? Even though I know these questions are a little bit harder because of the multiplying x, product rule, whatever. Are you guys starting to realize the pattern though? Feels like everyone's overthinking it by a little bit. But obviously it's your first time, so don't worry. This usually for year 12 students is the last topic that's taught, and it takes them about 4 or 5 weeks to wrap this around their head. You guys are doing pretty good for now.
Yeah, because it's just like ignoring all.
Yeah, that's it. That's a good point. There you go. Let's just say what Novak just said. You kind of ignore a lot of the crap.
Yeah.
And that's something you're not used to because to you, you're like, I've got to pay attention to every single detail. With this, however, you really don't need to worry about it too much. Last one, 3 marks. Let's see if we can get this out. Assume now, all right, what do we have firstly? Let's make sure we've got NC1, okay. Assume now that n is even. Show that for n is greater than or equal to 4. You can ignore that because the reason why the n is greater than or equal to 4 there, if it wasn't, if this was like, let's say 2 take away 3 is negative, now you're dealing with reciprocals, and we don't really want that when you're trying to expand binomials, right? Because they only work for positive even integers. So anyways, positive integers, not necessarily even. But in this case, assume now that n is even. So obviously n is like 2, 4, 6, 8, whatever. And it's telling you the first n is 4. Pretty much show this. Okay, now let's compare. So let's take our time and see what's happening. I did say this is 3 squared, 4 squared, okay, yep, equals n plus 1 Thinking. I am thinking. So now that n is even. I will tell you guys what I'm thinking in a second. I'm just trying to work out the answer because that's how you're meant to do this. You're meant to work it out before you start. All right. Minus 1 plus 3 squared minus 3 plus 5 squared minus 5 plus dot plus n minus 1 squared and c n minus 1. This is 9, this is 24. Nice. I know what's meant to happen, I just can't see it. If n is even, so if this was 4, this would have been n choose 0, n choose 1x. And then we're going to differentiate the original, right? Either x equals 1. So now that n is even. I need to get rid of all my odds in here. To get rid of all my odds at year 11 level. Can I do this in year 11 without learning series and sequence? NC1 is n. Let's see what happens with this. 9 n factorial over 3 factorial n minus 3 factorial. This is n minus 1 minus 2 minus 3 factorial. 3 factorial is 6, 9 divided by 6. No good. This is divided by 2. 2 even. Even plus odd equals 2 even. Divide by 2. Even plus odd equals 2 times the even. If n is even, is that true? N is even. If n is even, alright, let's see. 1 plus x squared. 1 plus 2x plus x squared. No, I don't like that. I'm a bit empty. Unless it is this. But I don't want to do it and just get it wrong. Alright, let's have a look. What year? 2011. HSC extension 1 math solutions. In equation part, oh, I substitute x equals, I got beaten in my own game. Doesn't matter, and divide by 2. Alright, shame. I should have realized that myself. Oh well, it is what it is. So, like I was saying, we've got to get rid of our odd terms, and I hope you guys can realize that this is exactly the same as this, except just divided by 2. So that's super important to realize. Let's go. Let's go back. And that result that I just wrote there, 2 times even, is equal to even plus odd, is exactly what's going to happen. And the only way that happens is instead of at this stage letting x equal to 1, I'm obviously going to let x equal to minus 1 at double I. So here, I'll let x equal to minus 1. And what should happen is this result. So let's look up here, x is minus 1, right? So NC1 minus 4 NC2 plus 9 NC3 minus, let's say, 16 NC4 plus dot 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 plus the last one's going to give you n squared minus 1 to the power of n minus 1, n choose n, equals, you guys still with me? 1 minus 1 is 0, and then 1 minus 1 is 0, so 0 equals to 0. Right? So it all cancels that, gives you 0. So what you've just proven there is this result. NC1 plus 9 NC3 plus, let's say the next odd after 16 is 25. 25 NC5 blah 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 must equal to, if I bring all my even numbers to the right hand side, I get 4 NC2 plus 16 NC4 plus dot 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 dot. So pretty much what you just proved is what I had written for you guys up here. You got to prove that odd equals even. Like I said, I got beaten at my own game. I think I kept telling you guys, sub this in, sub that in. I didn't even do it. Oh well. Odd equals to even. Once you know the odds are equal to the even numbers, then that means in your result up here that you've got NC1 up here, NC1 plus 2, 4 NC2, 9 NC3, blah blah blah. You replace all your odds for your even. So that means your evens are doubling, right? It's going to be double the even numbers. So let me write sub odd into final result of double I to get what I had written for you guys up there before, 2 times even. So essentially NC1 up here becomes 4 NC2, but 4 is 2 squared, so you get 2 squared NC2 plus 2 squared NC2 plus 16, which is 4 squared NC4 plus 4 squared NC4 plus dot 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 until your last term, n, choose n squared, which equals to n, choose n squared plus n, choose n squared, which equals to, what do we have in here? Equals n 2n minus 2, n plus 1. n 2n minus 2, n plus 1. Then the left-hand side, like I said, they're doubled up because you replace all your odds for your evens. So you've got 2 times evens, essentially, on the left-hand side. In other words, you've got 2 times 2 squared NC2 plus 4 squared NC4 plus dot 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 plus NCN n squared equals n 2n minus 2 n plus 1, and then you just got to divide by 2, and then you get 2n minus 3 n plus 1. You got to say again, just the way you guys saw the way I looked at my solutions, I only looked at the first line, let x equal to -1, because the rest, you have to realize the only way you're going to get rid of an odd here is by either subtracting it or by having a relationship between odds and evens. And because I saw that this result was exactly the same as this, just divided by 2, I knew that it had to be 2 times evens. And so I kind of knew what was happening. It's just that I haven't practiced this, so I would not have done x equal to -1 just off the bat there. But now that you guys have been exposed to it, hopefully you can think like that. You get stuck, go back. But that's only for odds and evens. This works very well. All right, I'll let you guys copy it down and ask me any questions you have. Looking to finish earlier. This question took longer than I thought. 7 marks, right at the end, like I said. And yeah. Let me just stop this recording.